So in this video, I'm going to recap hypothesis testing. So hypothesis testing is all about obtaining sample data and then looking at the properties of that sample to make inferences about whether the properties are the same or different as either the population or perhaps another sample which has been treated differently. So for example, if you had a team of basketball players and you wanted to test whether their heights were on average greater than the general population. So you would take a sample of those players, you'd measure their heights, find the average, and then using your statistical tests, you would conclude whether it was the same or different on average to the general population. Another example would be where you're comparing between samples. Perhaps you take a sample of male basketball players and you take a sample of female basketball players. You measure their heights and then you would test whether on average the heights of these two different groups are the same or statistically different. And I guess the important thing to note is that there is some uncertainty in making these comparisons because you're only taking a sample of the basketball players. You're not looking at every single one. If you were looking at every single one, then you would be able to conclude definitely whether they were taller or not taller. So the first kind of big concept that comes in for our hypothesis testing is the null hypothesis and the alternative hypothesis. So that's what we've got here. So the null hypothesis is the hypothesis of no change. So if you're looking at comparing the height of basketball players to the general population, the null hypothesis, or the one of no change, would be that the general population has the same height as the basketball players. Or in the case of comparing male and female basketball players, the null hypothesis there would be that the male players have the same height on average as the female players. Now there is an abbreviation that's often used for null hypothesis, and that is H0. Okay, it's just an abbreviation, it means the same thing. So in terms of the alternative hypothesis, this is the hypothesis of action, or you can think of it as the hypothesis of change. Okay, so you're not going to maintain the status quo. So in the case of looking at basketball players compared to the general population, the alternative hypothesis might be that basketball players are taller than the general population. If you were looking at comparing male and female basketball players, you might be interested in, you probably expect the male players to be taller than the female players, so that would be your alternative hypothesis. Male basketballers are taller than female basketballers. Again, there is a abbreviation for this one here, and that is H1. Okay, so H1 just means alternative hypothesis. So the next thing that comes into play is like this truth or decision table. So let's scroll down and have a look at that. So we've got two different options in terms of the truth. So we're going to focus on HO here, our null hypothesis. So either HO is actually true or HO is actually false. Now we have a decision that's made based on our statistical test, and for that decision we either decide to accept HO, so we think it's true, or we have our decision where we reject HO, so we think it's false. Now we can make a table with each of these options, which is what you see here. So the ideal case is like, okay, HO is true, and we've performed our statistical test, and we think it is true, so we're going to accept HO. So if we get this right, then that's all good because it's correct. We've accepted HO and it's true. On the flip side of that, we could have HO actually being false, and we could make the decision to reject HO, so we don't think it's false. So putting those together, again, it's good because we end up with the correct decision coming out. So the other two is when we have an error happening. So if we accept HO, so we think it's true, but actually it's a false hypothesis, then we end up with a type 2 error. Okay, again, we have an opposite. If we decide that, if we decide to reject HO, but it's actually true, we end up with a type 1 error. And these are what we're kind of concerned with when we do our statistical tests, okay, because we don't really want to be making errors. So the probability of a type 1 error is the chance of detecting an effect that is not present. So you can kind of think of this one as being a false positive. So a type 2 error, that's the chance of failing to detect an error that is present. So this is like having a false negative. Alright, so let's put an example around this. Let's say that we have someone that's on trial for murder. So HO, that would mean that it's the hypothesis of no change. So that's pretty much like they're not guilty of murder. They're going to go on living their life. Alright, so not guilty. H1 is going to be the hypothesis of change. So they are guilty of murder and they're going to go to jail or whatever else is a punishment. So applying this, alright, if they are not guilty and we decide that they're not guilty, then that's all good. We've made the correct decision there. If we decide HO is false, so that means H1 instead is true. So the person is guilty, alright, and we make the decision that they are guilty as well. That's all good, again, because we've made the correct decision there. So we have these two others which are not so good. So if HO is false, so that means that the person is actually guilty, alright, and we accept HO, so we decide that they're not guilty, that kind of means we're going to end up with like our murderer living in the general population without any kind of consequences. Okay, so if we're landing in this box here though, what that means is HO is true, so that means that person is not guilty, right? And we're rejecting HO though, so that means that we've decided that they are actually guilty. So in this one, we're going to have an innocent person sitting in jail. Alright, so moving on to the next bit. What we're going to talk about here is p-values. So a p-value is what we kind of look at when we do these hypothesis tests. And we can equate it to the probability of getting a type 1 error. Okay, so going just back up here, a type 1 error was the chance of detecting an effect that's not present or having a false positive. So in the example of the person who's murdered someone potentially, the false positive result is that they've been found guilty of murder, but in actual fact they didn't do it. Okay, so that's what we're looking at when we calculate our p-value. So there's a few different things that we can conclude based off this p-value that we get from our statistical test. So if we have a very, very small p-value, so less than 0.01 or 1%, what we can say is that there's very strong evidence against HO. So that means that we'd probably reject HO, our null hypothesis, and accept a H1 instead. If we get a p-value between 0.01 and 0.05, we've got strong evidence against HO. If it's between 0.05 and 0.1, we've got weak evidence against HO. And if it's greater than 0.1 or 10%, basically we haven't got too much evidence against HO because it's a fairly common event. Okay, the probability of getting this type 1 error is very common, so we don't want to make a conclusion against HO. There's just not enough evidence to support it. Alright, so the final kind of notes to put in here is that the type of test that you perform in order to get out this p-value depends on the data that you're given, how it's distributed, and so on. So there's a whole host of different tests that can be performed based on your situation, and these are what we're going to go through over the next several videos. The other thing to note is that when you calculate these p-values, what you're really assessing is the chance, assess chance of getting a certain result or more extreme. Okay. So if we go back to the example of the basketball players, say we draw out a sample and they've got an average height of 200 centimeters. We're not going to assess the chance of just getting a sample of 200 centimeters. We're going to assess the chance of getting a sample that's 200 centimeters or more. Okay, so getting that result or something more extreme. So in the case of heights, a larger one is going to be more extreme. So we'll look at that in a bit more detail as we go through the examples, but that's pretty much all there is for this video, and I'll see you in another one.